Before answering the problem, it is best to read the problem carefully and figure out what are the given numbers and figure out what it wants you to answer.
The problem states, for the circuit below, R1 equals 50 ohms, R2 equals 20 ohms, R3 equals 35 ohms, R4 equals 10 ohms, R5 equals 68 ohms, I1 equals 0.11 amps, I2 equals 0.142 amps, and the batteries are ideal. Part A asks, what is V1 and V2? Part B asks, what is the potential difference across R4?
Another tip I learned from taking physics is to draw or sketch. The problem gave us the resistance and the currents, so we will draw the two batteries with missing voltage and the currents I1 0.111 amps, I2 with 0.142 amps, and the resistance R1 to R5. R1 50 ohms, R3 35 ohms, R4 10 ohms, R2 20 ohms, and R5 68 ohms. Looking at the problem, it is best to use the loop rule.
Since there are two batteries, solving this problem requires that we look at each battery separately. We will start this problem by creating an equation for the left side of the circuit. We will follow the direction of the current indicated by the direction of the loop, which is clockwise, and start working the problem there. We will set the equation equal to 0, while on the other side is voltage 1 minus resistance 1 multiplied by current 1 because the current and the resistance are along the same line. Then we can subtract the sum of the currents multiplied by resistance 4 down the middle because current 1 branches down the middle of the two cycles and current 2 also meets there since it is traveling in a counterclockwise direction. Finally, we subtract the product of resistance 3 and current 1. We then follow the same steps for the second battery on the right. After setting the equation equal to 0 and following the direction of the current, which is going counterclockwise, we solve for V1 by writing 0 equals voltage 2 minus the product of resistance 5 and current 2 minus the product of resistance 2 and current 2 minus the sum of current 1 and current 2 multiplied by resistance 4. We can then substitute the variables for actual values given from the problem and simplify. After inputting values for the left side of the circuit, the final equation was 0 equals voltage 1 minus 11.965. We solve for voltage 1 and get 11.965 volts. We do the same thing for the right side of the circuit. After we substitute the variables for actual values given from the problem and simplifying, the final equation was 0 equals voltage 2 minus 15.026. We solve for voltage 2 and get 15.026 volts.
For part B, it is asking for the potential difference across R4. To answer this, we will use the equation the change of V4 is equals to the open parentheses I1 plus I2 close parentheses multiplied by R4. Then we will substitute the numbers and we have open parentheses 0.111 amps plus 0.142 amps close parentheses multiplied by 10 ohms. And this equals to 2.53 volts.